Okay, so we're going to talk about decision structure and Boolean logic. This is one of the most important topics to understand when it comes to programming because you will be using these a lot. No matter what language you will be coding in, the decision structures as well as repetition structures, which is in the next chapter, these will be coming up quite a lot in your work, in your everyday to day, just regular work. Now, these are all of the topics that we're going to cover today, and let's jump right into it. So, introduction to decision structure. What are they? It's pretty simple. Well, sometimes you will also hear selection structures, but it is an older term. So just call them decision structures. That's what I called them. That's what I've heard throughout my 4 years of college. We only said decision structures. Now, what are they? So basically, how they work, you have a couple of different types of them, but the general idea is if some condition is met, you're going to perform some actions. Usually, there's also another part to the decision structure, which says if the condition is not met, perform something else. So a couple of alternative ways for your program to run. Kind of think of it as you're standing in the middle of the road and there are different ways where you can go. So kind of, let me show you. Like we're coming in here and then we will have different ways for our program to go. We can either take route 1 or route 2 or route 3. So that's the general idea. Yeah, that's the general idea.
Okay.
Now here's a little flowchart that we can look at right here, a simple decision structure that we have. Now we are coming in just following the arrows. So if it's cold outside, this is our condition. Our condition will be shown inside of this structure right here. So if it's cold outside, then we will follow the true arrow because it is cold outside, and we're going to perform an action of wearing a coat. Now, if it's not cold outside, we're not going to follow this at all. The program will ignore this part, and we're just going to follow the line with false, and we're going to not do anything. So this is the general idea how decision structure work. You will have some sort of action somewhere. And this is the most simple one. This is the single alternative decision structure because we only have one alternative pathway for our program to execute, wearing a coat. Now, this is some pseudocode right here. So in general, this is how all of the languages are set up. Sometimes you will see condition will come after then, or maybe some languages do not use then at all. But this is the general idea of how these decision structures are set up. So if some sort of condition will be right here, you're going to put some sort of condition, in this case is it cold outside, then do something. Then these statements are going to be executed if this condition is true. Let's see. Relational operators. Relational operators come hand in hand with decision structures. Now we're going to have a little throwback to algebra, probably like 7th or 8th grade. I'm not quite sure, but a little throwback to algebra. So we have our relational operators. They are the same as in algebra, most of them. However, we have a couple of more. So this one is new. This one is very simple. This just means not equal to. Now this is greater than, less than, greater than or equal, less than or equal, less than or equal, and then the equal one. So some languages will have you use double equal sign to make sure that you're using this as a relational operator, but some languages but some languages will still let you use something like this. So it just depends on the syntax of the language that you are working with. Let's see, if-else statement. So this is the dual alternative decision structure. And again, most of these things, if you are forgetting what these terms mean, dual alternative, single alternative, just look at the name, and it's in the name. It's explaining it for you. So single alternative will provide only a single alternative for our program. Now, dual alternative, what is it going to do? It's going to provide two alternatives because duo equals 2, so it will provide two alternatives for our decisions, for our program to execute. Now look at this. We are adding something under false. So our previous program did not have anything under false. We just had arrow, some sort of condition, arrow, right? If it's false, if it's true, it went right here. So this was true, this was false. And there were some statements to execute. But this time, right here for a dual alternative, we are actually adding a new block of statements for our program to execute. Again, we're coming in right here. We're starting, this is our decision structure inside of a diamond. Is the temperature less than 40? If the temperature is less than 40, we're going to follow our true arrow right here, and we're going to display a little cold, isn't it? However, and then after that, we're just going to continue with the execution of our program. However, if the temperature is greater than 40, which means this expression evaluates to false, we're going to follow this arrow right here under false, and we're going to display nice weather we're having. So nothing too complicated. It just depends on how you want to set up your program. You could also flip them. So this is not the only way to use decision structure. It does not have to be this way. You can also perform something like this. You know, if temperature is greater than 40, you can check that too. And then you will just have to flip these two. So if it's false, you're going to follow this line. And if it's true, you will follow this line right here. So it does not have to be, you do not have to check if it's less specifically. You can also check if it's greater. And that way you just have to flip your true and false values, because again, if the temperature is greater than 40, then you're going to follow the true and arrow and display nice weather we're having. If the temperature is less than 40, you're going to follow the false, because our condition will evaluate to false in that situation. Now here's a little pseudocode again with your dual alternative decision, the one that we just saw right here. So this is the pseudocode for that. If some sort of condition, then perform some statements, else perform some different statements. And look at this one. This is our condition right here. Temperature is less than 40. So we're checking if temperature is less than 40, then we're going to print a little cold, get a code. If the temperature is not less than 40, then all of this will be ignored, and we're going to display nice weather and sunny. Now, comparing strings, this is one of the most popular ways where you would use your decision structures. You would be comparing strings, and a great example is passwords. So whenever you're typing your password in on any of the websites, what's happening behind the screen? Either they're matching your password to the password that you have in your database. So it's just a simple if structure. Again, if password1 equals password2, then we would like display something like display welcome, right? Welcome to the website. So, and you're being logged in. Else, if it's not, if the passwords are not matching, we would display something like try again, display, try again. And you would have that prompt that says, you know, type your password again, or passwords are incorrect, or something like that, or like forgot your password, all of that.
Yeah. In my notes, I actually wrote an example of it would be a password.
Yeah, exactly. So it's one of the most popular ones. Your password is saved somewhere in a database, which we also will get to the databases just a little bit later. Your password is stored somewhere in a database, and it's just a simple decision structure to grab that password and compare it to whatever you entered. If those two match, you're welcome to the website, you're logged in. If those two don't match, then you know you're not you cannot enter. So it's pretty simple. But this is another example. So we would create a variable that would temporarily hold your password, declare string password. Again, this is all pseudocode. This is not any of the language. This is just fake language. Then we would ask the user to enter their password by displaying enter the password and getting some input from whatever they typed. And then in this example, we already have a password that's supposed to be for that user, which is Prospero, which never happens in the programming world. You will get that password from the database, but for the sake of this example, the password should match Prospero. So
Okay.
this is what we're checking. If password equals Prospero, then we're going to display password accepted and whatever, let that person in to our website. And else, if it's not, if these two are not the same, that we're going to display sorry, that is not the correct password. And here is just a little example. See, if somebody entered Ferdinand right here, we would display sorry, that is not the correct password. If somebody entered Prospero, password would be accepted. And that's what we would say, password accepted. Another ways to compare strings, you can compare either string and string. So in this case, name one, name two, these two, just think of them as strings. You can compare and see if these are the same. You can also compare strings and string literals, which is, this is our string literal right here, just a regular word. So months equals, not equals to October. This is what's being checked in this statement right here. And months should be holding some sort of value. So it's not just months, it should be holding like any months, any word that it can
January,
hold.
February, things
Yeah.
like that. Okay.
Yeah, it can be anything. So we're just checking if whatever this variable is holding is the same as the word October.
Okay.
They are case sensitive, so generally those comparisons are case sensitive, which means dog with a capital D would not be the same as dog with the lowercase d. These two are different because of the way languages compare strings. So from your first chapter, if you watch the lecture video, we introduced ASCII and Unicode. So most of the languages, the coding systems for to translate those zeros and ones into actual letters of the alphabet that we have, letters and numbers. So most of the languages, how they compare strings, each of these characters will have a Unicode value assigned to them. So for example, I don't remember quite well, but let's pretend that, for example, A has a value of 65 in the Unicode table, and lowercase a will have a value of like 96 in a lowercase a will have a value of 96 in the Unicode table. So even though these are the same letters, the computer will think of them differently because of that special coding that we have for the characters. So anytime a comparison is made, what computer does, because it cannot understand if this is a capital letter of its a lowercase letter, so your computer cannot make the difference. You have to actually tell it if it is. So it's going to look at the Unicode value of the capital D, which would be 65, whatever. Let's put like 68. And then it's going to look at the lowercase d, which would be, let's say, 100. So it will compare them. It will say that this one is lower than 100. So these are not the same. These are not the same strings. So this is how most of the comparisons are done. Let's see. Nested decision structures. So nested decision structures is whenever you just stack decision structures inside of a decision structure. So it's quite simple. It might sound a little bit complicated, but literally it's nothing too bad. It's just literally you're putting a decision structure inside of a different decision structure. Let's look at this flowchart right here. So we are coming in right here. This is let's see, what are we doing here? So we are trying to qualify for something at our job. Oh, we're qualifying for the loan. So the first thing that's going to be checked if our salary is greater than or equal to 30,000. Now, if it is true, we're going to follow this arrow right here. However, if it is false, we're going to immediately be not qualified for the loan. And we're gonna see you must earn at least $30,000 per year to qualify. And we're gonna go straight to the end. So if we do not meet the first condition, the program will not even let us do any other comparisons. Now, however, if we qualify with the first qualification that we have, if our salary is greater than 30,000 or equal to 30,000, we're going to follow the true line right here. And then we're going to be checked for another condition, which is how many years have we been on the job? Now, if we have been on the job for more than 2 years, then we're going to be qualified for the loan. It's going to display you qualify for the loan, and it's going to take us straight to the end again. However, if it is false, even though we qualify salary-wise, if we don't qualify with years on the job, we're still going to get denied for the loan. And something's going to be in front of our screen that's going to say similar things to you must have been on your current job for at least 2 years to qualify for the loan. Let's look at a different example with pseudocode. Again, this is the logic for grading. Now, this is actually something that is still used whenever you do Moodle or whenever you do any other kind of schoolwork. This is actually used, the logic behind the grading part. So if your score is less than 60, then we're going to display the grade as F. If the score is less than 70, display D, and so on. 80 is C, 90 is B, and else is A. Now, you can notice right here that we do not have condition here for A, right? Why is that? Because we already checked every other possible condition before we get to A. So how this works, we're going to check the first one, if score is less than 60. Now, if our score is not less than 60, we're going to move on to our next if else. So this is going to be the first thing we check. If our score is not less than 60, we're going to move on to the next one right here. Now, then we're going to check if our score is less than 70. If it's not less than 70, that means it's greater than 70. So it's in a range from 71 to 100, right? So we're going to move on to the next one. If we're going to check if the score is less than 80. So in this case, if it's not, let's say our grade is 96. So this is going to be evaluated to false again. So now we know what that tells us, that our grade is somewhere within 81 and 100. Again, we're moving on to our next one. If the score is less than 90, our score is not less than 90. So we're moving on to the next one. And that tells us that our score is somewhere between 91 and 100. And then see, we don't have anything else. This is our last possible decision to make, our last path for a program to go. So that's why we're going to display grade is A, because we already tried all of these. So we know for sure our grade is within the range of 91 and 100, which makes it an A. So again, this comes with a very interesting logic, because you would not be able to do this if you flip these values, right? If this would come first, display grade is A. For example, if we're checking if the grade is less than 100, right? If we check if score, let's say we're checking, this is the wrong example. This is how our program would not work. So if we're checking our score to be less than 100, right, which could be, for example, if we have a 96, which will evaluate to true, so we would display grade is A. Grade is A. So this means grade is A. So if score is less than 100, we would display grade is A, and then we would carry on with else if score is less than 90, and so on. So the same idea as here, but we would put this one first, this one second, third, fourth, and fifth. Now, again, this might seem good in our brains, but our computers do not work the same way as we do. And that's the main problem. So you have to explain everything to the computer, and you have to be very careful when you're working with decision structures or nested loops. Now, let's look at this example. If we have a value of 96, we're going to be checking the first condition right here, score is less than 100. And yes, it is less than 100. So we're going to display grade equals A, which in this condition is true, right? This condition is true. 96 is an A. However,
So
let's say, yeah, let's say we have like 72. Let's say we're working with a 72. We're going to come in, we're going to check if the score is less than 100. Yes, the score is less than 100. It is 72, but still our computer will display A because this condition is met. And for the computer, if the condition is met, that means the job is done. That means we do not have to do anything else. we're good, right? 72, well, 72 is not A, but the computer does not know that. So you have to be very careful with writing these decision structures. Do you know how to fix this problem? There's a very easy fix to this. Okay, so how you would fix it, instead of checking your score to be less than 100, what you would do, you would check it if it's greater than 90
Okay.
first. And then the next one would be to check if it's greater than 80. So this way, we're checking it from 0 to 60. The first thing that we're checking, 0 to 60. But in this case, we're checking from 100 to 90. The first thing that we're checking if our score is greater than 90. So in a range of 91 to 100. Then the next one, we're going to be checking 81 to 90 and so on and so on. So this is what we would be checking.
Okay.
Case structure. Case structure is something very interesting. It does not, it's not usually a thing that you would use in your code. You would mostly use your nested decision structures. These are the most popular ones. But there is a thing called case structure. And what that means is you're just going to use your variable. So instead of using your conditions, you're going to use a variable. Now, in this case, this example is very simple. So we have a variable called month, and based on which value is stored in that month. So for example, if we assigned months to variable number 1. For right now, we're storing 1 in our variable month. If this variable has some sort of value, you can assign different things, your program to perform different things based on what is stored in that variable. So if 1 is stored, you can see it right here. If month equals 1, we're going to display January. If months equals 2, we're going to display February. If months equals 3, we're going to display March, and so on, so on, so on. You can go up to 12 because there's 12 months, and your default would be error invalid months. Your default would be for anything that is not a number from 1 to 12. Or in this case, in this exact example, from 1 to 3. So anything that's not 1, 2, or 3 would be automatically defaulted, and it's just going to display error and valid months. So this is how case structure works. They're based, instead of being based on expressions, they are based mostly on variables. Logical operators. This is the last thing that we're going to cover today, I think. I think this is the last topic, logical operators. These are also very popular, very important to understand. There's a couple of them. So if you want to create complex expression, which means 1, 2 or more expressions, and you want to combine them and check them at the same time, you would use your logical operators. So and evaluates to true only if both conditions are true. Or I will show you an example of this. Or evaluates to true if either one of the conditions is true, either the first one or the second one that you're checking. And not, what not does, it's just going to reverse the whole value of your expression. So if you have an expression that evaluated to true, if you put not in front of it, it will reverse it to false. And if you have an expression that evaluated to false and you put not in front of it, it will evaluate to true now. So it just reverses the whole value of your expression. Now let's look at this example right here. So we're checking if our temperature is in the danger zone. Not quite sure what that means, but just let's pretend there is a danger zone. Now, example of and. If our temperature is less than 20 and our minutes are greater than 12, then we're going to display the temperature is in danger zone. So this thing right here will be executed only if our temperature is less than 20. So let's say our temperature is 19, and if our minutes are greater than 12. Minutes are greater than 12. So let's say our minutes are going to be 13. So only in this case, it will evaluate to true, and we will see this message being displayed. If any one of these would not be true, for example, if our temperature would be, let's say 21, right? Our temperature is 21, and our minutes, let's say our minutes are actually good. Our minutes are 14, this would still evaluate to false because we do not meet the conditions of temperature being less than 20. So this is the main thing when it comes to end. Just make sure that both of the expression evaluate to true. Only that way you will get to the code part that is executable within that if structure. Or it's again very simple, or needs to be needs only one condition to be true for the whole condition to be evaluated to true. So in this case, we're checking if our temperature is less than 20 or our temperature is more than 100. Then the temperature is in a danger zone. So you're checking something within actually, if you're checking something outside of the range of numbers, so in this case, our x needs to be either less than 20 or x needs to be greater than 100.
Yeah.
So again, pretty simple. If either one of these is true, the whole expression will be evaluated to true, and the temperature is in the danger zone will be displayed. So let's say if x is 102, even though we do not meet this condition, we meet this condition. Therefore, this would be evaluated to true. Now, the not example is, again, it's very simple. The only thing you need to know about not is that it's just going to reverse the truth of your expression. So we're checking if the temperature is more than 100 in this case. If the temperature is more than 100, not, we have a not right here in front of it. So let's say our temperature is 102, which would be evaluated to true, right? This whole thing will evaluate to true. However, we're gonna have not, and so instead of true, we will have false. So we will not be displaying this message. This is below the maximum temperature. However, if we have a lower amount than 100, let's say we have 80, if our temperature is 80, then this condition will be evaluated to false, right? Because our temperature is less than 100. So we will evaluate this to false. However, we have not right here. It will change our expression to true. And then we're going to print this is below the maximum temperature. So based on this decision structure, it tells me that 100 is the maximum temperature. And we're just checking if our temperature is below the maximum temperature or not.
Okay.
And the last thing, let's see, two more, the range checking and short circuit evaluation. So short circuit evaluation is something that is supported by some of the languages. I think Python and Java both support this. We use it for increased performance. So since your computer will be doing a lot of processes at the same time, it will want to save as much power as it can, as much memory, as much space as it can. And one of the ways to do it is short circuit evaluation when it comes to logical operators. And operators, since we know that both of the expressions, expression 1 and expression 2 needs to be true, if our first expression is false, we would not even be checking expression 2. And now that makes sense because expression 1 is already false and we have an and we know that we need these two to be true for expression to be evaluated to true. So if our first one is equal to false, we will not be checking the second one at all. So your computer will just skip it as a whole. And the same idea comes to the or operator too. Now we have expression 1 or expression 2. In this case, we know that we only need one side to be true. Either our left side or our right side of the expression needs to be evaluated to true. Now, if this one evaluates to true, we will not be checking the second one because we don't need it to be checked. This whole expression will already be evaluated to true because only one of the expressions needs to be evaluated true for the whole thing to be true. So this is what short circuit evaluation is. It's just you checking only one of the expressions based on whatever the result of that expression is. So for AND operator, we're checking if the first one is false, and for OR operator, we're checking if the first one is true. Range checking, again, another useful thing to remember. So if you want to check if the number is inside of a range, you would use AND. And if you want to check if a number is outside of a range, you would use OR. So in this case, if we're checking if X is between 20 and 40, we would use and. So we're using if x is more if x is greater than or equal to 20 and x is less than or equal to 40, then we're going to display that the value is in the acceptable range. However, if we want to check for the number outside of the range, we're going to use or. If x is less than 20 or x is greater than 40. Both of these would be outside of this range right here between 20 and 40. Boolean variables, sorry. One last thing, Boolean variables. So Boolean variables, Boolean is something that can only hold either true or false. You will mostly use them with your decision structures. So in this case, we have a Boolean variable is lunchtime. So we're checking if it is lunchtime. Now, if time is greater than or equal to 12, then our variable is lunchtime will be set to true because it is lunchtime. You know, if it's past 12, it is considered lunchtime. However, if it's not, if it's anywhere between 0 and 12, then it's gonna be not lunchtime and the variable will be set to false. Oh, sorry, not 11, not 12, 11:59, since we're checking inclusively. So anywhere between 0 and 11:59, that won't be lunchtime. So that's pretty much it. That's all I had for today. Let me stop recording.